when GPS goes dark, whether deep in the rainforest, lost in the labyrinth of a disaster zone, or off the map in a rural region, what keeps navigation alive?
In simple terms, geolocation is to find people or objects. It could be you, it could be your lost phones, or it could be ambulances.
Here lies the dangers of current traditional online GPS systems, where time is of the essence.
The geolocation system works, everything is wonderful, but when it doesn't work, life could be at danger.
That's the genius behind I-NAV, Inverse Navigation, a groundbreaking geolocation system designed for GPS-denied environments. Unlike traditional routing methods that guide you from point A to point B, I-NAV works backward. It uses a few breadcrumbs of human input to determine where you are.
So our framework is called Inverse Navigation, or INAV. Now, why inverse? It's because for traditional routing algorithms, you have a specific destination and a starting point, and then you find the most optimal or shortest route from the starting point to the destination. In our case, we actually don't know a specific destination. We only go off of vague user inputs from questionnaires, such as what's the last landmark you passed, how long did you travel, perhaps what direction did you travel, what is your mode of transport, etc. And based off that, we try to figure out what are the likely destinations that this person could have gone in. So how we do this is basically in two distinct steps. The first step is we find the maximum reachability. So we try to find exactly how far, like the maximum range the person could have traveled given these parameters. And then we try to find the likely destinations. So in that time, like they're not, if it's like they're traveling for 10 minutes, they're not likely to be like 50 miles away, but they're also not likely to be like half a mile away. So we try to figure out like which areas that they're likely to be. And based on other inputs like direction, other landmarks passed, we can figure out we can pinpoint the area to a more narrower search zone.
Once I-NAV gathers this data, it uses a modified Dijkstra's algorithm to generate a high-resolution travel map. It overlays this with an adaptive Gaussian likelihood model, AGLM, producing heat maps that highlight the most probable areas the user could be in, essentially reversing the navigation process.
So how the algorithm works is first we get information about the road networks from mostly an open source place like either OpenStreetMaps or Google Maps or something like that. Then that information, we actually discretize it. What that means is we convert the map into a discrete graph network where each block or pixel, you could think of it as, is about 11 meters by 11 meters square, which is a good precision for a road network. Then each of the boxes in the grid is given a cost value, which is essentially how much time it takes to cross over that box. And this is based on the road networks. So a highway, for example, since that is a higher speed limit, it'll have a low cost, as traveling a distance over the highway doesn't take much time. But for a more urban network, like a downtown road, they'll probably have a higher cost value because it takes a long time to traverse that same distance. So that's essentially how we make the grid into a cost network. And then based on the travel time or other budget questions, we start from the starting route and then see how far we can go based on the budget we're given into the road network. This gives us the maximum reachability.
In experiments comparing I-NAV's predictions to Google Maps and Open Route Service, both of which use live data and internet connectivity, I-NAV achieved comparable results. In fact, in one test, its travel time accuracy deviated by only 1 to 2 minutes, and its probabilistic maps aligned with commercial isochrones at nearly 80% overlap. Even better, it did all of this offline with zero internet or GPS dependency.
So implementation-wise, we would like to partner with public health and emergency agencies. It is desirable to test INAV in real crises such as disease outbreaks or wildfires, especially when GPS signal is weak. Our ultimate goal is to turn INAV into a life-saving tool that works when the location data is needed the most.
Looking ahead to upcoming developments include machine learning integration, multimodal navigation, environmental features, and scalable simulations. In an era of increasing environmental uncertainty and digital reliance, INAV offers a refreshing approach. Simple, smart, and scalable. INAV reminds us that sometimes the best way forward is to think in reverse.